This conference will now be recorded.
Okay, this session is getting recorded. Today is 17th October and this is done for Abhishek. Okay, so we are looking at one of the, so Abhishek, what we are doing is we are looking at one of the bottlenecks that I've really faced in the recent project. Okay,
Okay.
unfortunately, as I told you, I don't have access to those applications anymore because the project is done. So I'll not be able to show that. I really wanted to show that, to be honest. Okay, because visually when you see that, it will be there in your mind and you can speak about that bottleneck much more confidently. Okay, but now that it's not there, I cannot do anything. So before talking about the bottleneck, we'll quickly try to understand the architecture. Okay, that's the first thing, right? Once we know the architecture, then we can know more about it. Okay, so it is a simple application which supports only 70 to 80 concurrent users. Okay, only 70 to 80 users, and generally, if the number of concurrent users are less, typically these applications are internal applications. Okay, when I said internal applications, that's the term that I have coined. Okay, what I meant by internal applications is this is used by the internal staff of the company. Okay,
Okay.
staff. Okay, internal staff of the company. So can you name some, sir? Okay, can you name an application which is used by internal staff? Okay, can you name them? So whatever this application is a completely different application. I mean, it's not the application that I'm giving example. Okay, but let's assume, okay, you go to the bank. Okay, you go to the bank. Okay, with the cash. Okay, and then you're going to deposit. Okay, so when you're going to deposit, what would you do, Abhishek? Okay, when you go to the bank and you say, I want to deposit this 50,000 INR. So where would you approach?
We'll approach the cashier.
Okay, so typically they are called tellers or cashiers. Okay,
Yeah.
so okay, cashiers. So what would they do? They take your money on the system. They do something, and they give you a slip saying that the money is deposited, right? So
Yes.
whatever they are doing on the system, what they are doing, they are accessing. Okay, they are accessing the banking application. Okay, banking application. Okay, so on that banking application, they are opening. Okay, they are opening your account. Okay, they're opening your account and then they're depositing money into your account, right? Depositing money into your account. Do you agree with me, Abhishek?
Yes, sir.
Okay, so this, whatever the application they are opening, right? Whatever, okay, the application they are opening, right? That is internal to the banking staff. You cannot access that application. You are getting
Yes.
it? Okay.
Yes.
Typically, this
Yes.
application is called teller application. I know this because all my life I've worked in the banking industry. So I've done performance testing for teller applications as well. Okay. So the guy
Okay.
who deposits the money typically is called as a teller. Okay. Typically
Okay.
is called as a teller. Okay. Okay. Typically they are called as a tellers. Okay. So
Okay.
that application is also a teller application. Okay, so this teller application is only can be accessed by the internal staff of that bank, ICICI or HDFC or whatever the bank. It can be accessed only by that internal staff. But ICICI or HDFC, it's a big bank. Even those teller applications, you might have 1,000 to 2,000 concurrent users. Okay, because the bank is big. So whatever the application that I was doing performance testing, maximum that can be the concurrency that they are achieving is only 70 to 80 users. So they have only one host machine. Okay, it's a simple. I mean, you see, it is 70 to 80 users. It's not too much load, right? So you need not
Yes.
have to have big infrastructure. Okay, the host machine. Okay, the configuration is Windows Server. Okay, 2008. Okay, R2 machine. Okay, so it's a Windows machine. The host machine is a Windows machine. Typically, you will have Unix machines, but this server is a Windows machine because the application is based on .NET. The application is based on .NET. Okay, I'm telling all this because you need to talk about this in your interview. Okay, so that's what
Okay.
it is. When you talk about this bottleneck as well, you say this is a .NET based application. Okay, it's used by only 70 to 80 users. So it is built on Windows Server 2002. Okay, and as I've told you, it's a .NET based application. Okay, on the backend, typically if it's a .NET based, you have a SQL Server on the back. for the database. Okay, for the database, it was a SQL Server.
So one question. So in Windows Server, will it support the Java application as well?
I don't know. Typically, I haven't seen a Java application hosted on Windows. I don't know for sure will it support or not because I haven't seen that. Okay, but
Okay.
if it's a Java application, there is no reason why they have to go to Windows Server 2008 because
Okay.
Windows Server 2008 is considered to be little less secure and also performance-wise, people don't prefer that. Okay, if it's a .NET based application, they don't have a choice. They go with the Windows Server.
Okay.
You're getting the point, huh?
Yeah. Because our project is also Windows Server. So our application runs like backend with SQL, and they're saying like Java application. So I was like,
Java application. So are you
yeah.
sure it's a Java-based application?
Yeah, we used to check the GC and all everything. So with
No,
that,
.NET is the GC and all that.
okay.
Any application you can check the garbage collection.
Mm-hmm.
So could be. That's what I'm saying. I'm not sure. Could be.
Yeah.
Okay.
Yeah.
So, but at least I haven't seen it. Okay. So, and the
Okay.
server is IIS. Okay. So,
Okay.
after IIS, this is a web app server. On this IIS server, this .NET application is hosted. Okay. And then you have a Microsoft SQL Server on the backend. And both this IIS server, the web app server, and the database server, both of them are on the same host. Both of them are on the same host. Typically, what happens is you give one host to SQL Server, one host to IIS. But here, what did they do? Since it's a small application and supports 60 to 70 users, they don't have a separate host for IIS server, separate host for SQL Server. Okay, are we clear so far?
Yes, sir.
Okay, so on the same host machine, I have the IIS. Okay, I have the IIS server, and I have the SQL server. This is the database, and this is the web app server. Okay, this is a web app server. Okay, and
Yeah.
okay, this is the web app server, and this is the DNS. Okay, so on the same host machine, on the same Windows Server 2008 machine, okay, on the same host machine, they have installed the IIS server on which they have deployed the they have deployed the .NET. Okay? They have deployed the .NET. Okay,
Okay.
are we
Okay.
okay? Yeah.
Yes, sir. Yeah.
Okay. So on the same host machine, again they have installed the Microsoft SQL as well, and these two will communicate. Whenever they have to fire the query will be fired on the database. Are we clear so far?
Yes, sir.
Okay, so what is happening is obviously the response times are really high. Okay, the response times are in the order of uh, 12 seconds. Okay, 12 seconds, 13 seconds, 15 seconds. Some of them are like 3 or 4 seconds. Okay, so 3 or 4 seconds they are okay. Okay, 3 or 4 seconds they are okay. Since it's an internal application and it's not used by the external world, so it said it may not have to be 2 seconds, 3 or 4 or 5 is also fine. But so anything which is greater than 10 seconds, this is what their concern is. Okay, so
Okay.
and then immediately what obviously we have done using the Jmeter, the project. Okay, applied this 70-80 users, and we have captured the response times. They are in the order of 12. Some at least 30 to 40% of them are in the order of more than 10 seconds. Okay, which is a concern.
Okay.
So what we have done is we are troubleshooting the issues, okay, with the help of the developer. So what is the developer? What is the first thing the developer done is, okay, they have sent me
Mhm.
this document, okay. So SQL high CPU troubleshooting checklist, okay. So she wanted me to go through this list and see what is the problem, okay. So
Mhm.
how we come to the conclusion that SQL Server is the problem is, okay, SQL Server is the problem is. So the CPU utilization of the SQL Server we have looked at. How did we look at? Let's say this is my Windows Server 2000. Whatever the machine that I'm sharing, let's assume that is the Windows Server 2008 R2 machine. Then over there, go to the task manager, look at the performance of it. Okay, the CPU was consistently 70. Okay, CPU
Okay.
utilization under the load with 70 users. Okay, 80 to 90. So CPU utilization was very high. Memory was okay. Okay. Then immediately what did I do? The process is, okay, I look at the IAS process. There is IAS server, right? related to that, there is IaaS process going on. The CPU utilization, okay, was 20 to 25%. Okay.
Okay.
But the process related to SQL Server, here I don't have those process. Okay, I have some other process like Chrome, and then this is GoToMeeting and other things. But the process related to SQL Server was consistently taking 70 to 80%. Okay, then immediately I know that SQL Server is the issue. Are we clear so far?
Sir, you have checked during execution or post execution, you have checked it, these things, utilization
While execution only.
while execution. Okay.
If you wanted to check post execution, then you have to open the performance. Okay.
Yeah. Okay. 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 Yeah.
And add the counters. Okay. Add the counters. Okay. Data, define the data collector set. Okay. And then user defined data collector set. And then add the counters. Okay. So the counters related to all of them. Okay. Especially the CPU utilization. CPU utilization is percentage processing time. Instead of the total, you have to look for each process. Okay. Each process. So I've done it while the execution is carrying on, not
Okay.
after.
Okay. Okay.
But not that we cannot do it. We can do it after the execution as well. Okay, the process level also we can capture and do it after the execution also. Okay, so while the execution is going on, I have looked at it. So here almost you see every process, Chrome process and this GoToMeeting process, everything is 0 or probably 7%. Some of them are 6 or 7, 2 or 3. Okay, and overall CPU utilization itself is 9 to 11%. So imagine what each process will take. Okay, typically less. Okay, but there the overall CPU utilization was 90 to 100%, and there most of it is used by SQL Server, and also some of them is used by IaaS, and remaining everything else, nothing was there. Remaining everything else like this 0 or 1 or 2 was there. So it's a good indication that your application is consuming all the CPU, nothing else on the system. Are we clear?
Yes, sir. Yes, sir.
If something else is there installed on the system, okay, and that is consuming, then immediately you will report saying that other than your SQL Server IaaS, some other applications are running on your server and they are consuming the high CPU. Okay, so you inform the Windows team or the developer. But in my case, clearly it is the SQL Server and the IaaS server taking all the CPU. Out of that, SQL Server was taking a lot of the CPU. So I know the issue was in the SQL Server. Okay, this is what my approach was for this issue. Okay, then immediately she sent me this saying that SQL high CPU troubleshooting checklist. Okay, then I was going step by step as to what it says. Okay, from Windows Task Manager, check the overall CPU utilization. That's exactly what I've done even before reading the blog. Okay, overall CPU utilization. Okay, from the Task Manager, check SQL Server process utilization. Go to the process, and I don't have the SQL Server installed on it, so and it's not even, it's not there, so it's not showing. If it is installed and it's running, the process related to SQL Server will be here, and it will show how much CPU is utilized. And you have to check while the load test is going on, not after or before. Okay. So after also you can do it. Okay, is the SQL Server CPU constantly above 70%? So yes, that was the case with me. It was consistently CPU constantly greater than 70%. So that was the issue. So there were few more things he wanted me to look at: the privilege time, process time, user time. If overall processor time is the privilege time plus user time, this is what people say. Somewhere, yeah, you see, overall processor time is the privilege time plus the user time. Okay, so user time is what is taken by that particular, let's say SQL Server. What is the time taken by the SQL Server? Okay, privilege time is the time taken by the OS. Okay, time taken by the Windows Server itself, and also there will be some work of your user will be done on the privilege time as well. Not everything, but privilege time usually will be something related to your OS that will be run on the privileged mode, and some work, most of the work related to the user will be done with the user time itself. Some of the work done by the some of the work of the user will also be done by the in the privileged time, but that's very less. Okay, user here is the SQL Server. Okay, don't think that user, I am the user. User time here is Chrome is the user here. Okay, Chrome is the user. Okay, this is the user, this is the user. So that's what it is. Okay, so
Okay.
and how do I get this privilege and user time? You can go to the, as I've told you, you can go to the
Person.
performance and you can get it. Okay,
Yeah.
from the
Yeah.
performance you can add it. Okay, so let's say performance. Okay, so data collector set will collect the data. Okay, so and then let's say I wanted to add it. Okay, so processor and privilege time is what I wanted to add it. Okay, of the local computer, and I think you can add it on the process level as well. Which process you? So overall you can add it. Okay, privilege time, but for each process also I think you can add it. I think, but I haven't seen it yet. For each process, I think it looks like it's not there. All the instances. Okay. So for each process, it's not there. Overall privilege time is what you get. Okay. Anyways, okay. So it's a fine. Okay. So what he is saying is, if the privilege time is more, then ask for the Windows team to look into why it is more. Because typically the privilege time is related to the OS related stuff. Okay, which is Windows Server 2002. It has nothing to do with your SQL Server. It has nothing to do with your IaaS. Okay, it has something to
Okay.
do with the OS related activities. Okay, so
Okay.
if the
Okay.
privilege time is about 25%, so we have to engage the Windows team, and if there are any patches, they will apply. This is what is given. But my privilege time was not over 25%. Certainly not, because the SQL Server plus the IaaS itself was taking 90%. Okay, so privilege time was not over 25%. So there's nothing my Windows team could have done. Okay, now you look at it. This is where the actual work started. Okay, check the below configuration from SP configure and make sure they're as per the best practices. So I went to the SQL Server. I have executed this query. Okay, SQL Server, you can execute the queries, right?
Yeah.
Yeah. So I have executed this query sp underscore configure. Okay, I have executed this query called sp underscore configure. Then it has shown me all of this. Okay, and I have made sure that these are as per what is here. Okay, you can edit this sp and this configure table. Sp underscore configure is the configure table. Okay, so sp underscore configure and you press run, it will show this, and you can edit this as well. If something is not as per this one, you can go ahead and make changes to this sp underscore configure table. This is what is a good combination. For me, this cost threshold for parallelism, it was 1, I've changed it to 5, and this was 0, I've changed it to 1. Max degree of parallelism was some other number, I've changed it to 0. This is supposed to be a good practice, so I've changed it to 1. It has helped to improve the performance to certain extent. Okay, you can say
Okay.
that there is a table called sp underscore configure table, and in this table, as per the best practice recommendations, there are some settings. These settings have some recommendations. You remember this cost threshold for parallelism, it was 1 for me, I've changed it to 5, and max degree of parallelism, it was number 4, I've changed it to 0, and as per the recommendation. It has helped to certain extent to improve the performance. Okay, as soon as you talk about these tables and then these settings, right, they know that you have actually done the engineering. Okay, or you have identified the point. Are we clear, Abhishek, so far?
Yeah, sir. So SP underscore configure. So what does it really do? Like.
It is a table, Amma. It is the SQL
Okay.
Server. SQL Server, every server has some settings. Okay,
Okay.
Oracle has
Okay.
a settings. Okay, SQL Server has a settings. Even IaaS, even though it's a web app server, it has its own settings. Apache Tomcat, it has its own settings. Depending on that setting, the server will work. So depending on
Okay.
this setting, the SQL Server will work. And if I wanted to look at what are the settings, okay, if it was Apache Tomcat or IaaS, you go to some file and then you go to the settings and then you change the settings, right? Even LoadRunner has some settings, right? Runtime
Yes.
settings,
Yes. Yes.
right?
Yes.
Depending
Yes.
on the settings, the LoadRunner will work. So the SQL Server, depending on the settings of the SQL Server, the SQL Server will work. So there are some best practice recommendations. It has to be as per this best practices. So somehow they messed around this, so I went back and changed this. Okay.
Okay. Okay.
And how can I look at the settings on the SQL Server? How can I look at the runtime settings on the LoadRunner? You go to property. I mean, you go to certain area and then click on runtime settings, and you will get it, right? So here for SQL Server, it is simple. You run this query called sp_configure, and you will be able to see it. Okay, the configuration settings.
Okay.
Are we clear about so far?
Yes, sir.
Okay, and you can modify this. You know how to modify the table, right? So you can modify that. Okay, so you can do a simple Google research. Okay, how to sp configure table. Okay. So it will tell you how to. I don't know nothing. You know, I looked at whatever is here and I'm done. Okay, simple. What I've done is, okay, this is for modify. Okay, syntax for SQL Server. If I have to modify a value, this is how I modified it. Okay, so if I have to, here see list all the configuration table. What did I do? You need not have to do select start from sp configure. Nothing. Just say sp_configure with a semicolon and run it. It will give you all the values. Okay. But if you need to modify it, you say sp_configure, and what is the value that you have to modify? Let's say I wanted to modify affinity mask. So you put affinity mask here, okay, and then configuration value, whatever the value that you have to give, you give here. So option name and the value, everything, just I copied this query as it is, pasted it. Only instead of option name, I've put this option name affinity mask, and whatever the value that I have to want to give, I've put it here. Let's say 0, I put 0 over here, copied it and executed it. That's how I've done. So you see, they are changing some settings for Hadoop. What did I do? Configure name, Hadoop connectivity, value, this is the value that they have. Since it has multiple values, they have put it in open braces and close braces. And finally, they said reconfigure, they ran this. So once you run this query, you have to run this reconfigure so that these values will be saved or locked. Are we clear now?
Yes, sir. Yes, sir.
Just you wanted to look at it, just to say sp configure with a semicolon, run it, you will be able to see all these values. You wanted to change it, whatever the value that you wanted to change it, put that value here, put that name here, value here. So if I have to change affinity mask, put affinity mask here, and value, if I wanted to give 0, put 0 over here, and it will. Are we clear, or should I show it to you?
Yes, sir. Yes.
Okay. So you're not overwhelmed so far, right? Okay.
Yeah.
It is still fine, right?
Yes, sir. Yes, sir.
Okay. You put affinity mask here and value that you wanted to use. Okay. Run this query on the SQL. Okay. And it should. So this is what is done so far. Did it help? Not much, but to certain extent it has helped. Okay. Now, what did I do? So now to get the top 10 queries which are consuming high SQL. Okay. So just I've copied this query, whatever the query, I didn't try to understand whatever it is. Okay. Just copied this query from top to bottom and executed on my SQL. Okay. And what did it give? Surprisingly, it gave the top 10 queries which are consuming high SQL. Okay. Which are consuming high SQL. Are we clear now?
Yes, sir.
Okay, I'm sending this article to you on the chat window. You can get this article stored. Okay, and okay, I can also send it to you on the WhatsApp as well. Okay, so what it will give you, there could be hundreds of queries that could have executed on your SQL query, but it will give you the top 10 queries which are consuming high SQL. Okay, top 10 queries which are consuming high CPU utilization. Okay, then I reported it to the developer saying that these are the queries which are consuming high CPU. Are we clear?
Yes, sir. So one question, maybe this question looks funny. So this query can, so we have a now I'm relating to my project. So we have a pre-prod environment. So the database through SQL developer, I will connect to that pre-prod environment, and can I run this query and see the results as well? Like we need to run it on the SQL server only.
Yes, you can definitely. Why not?
Okay,
Okay.
okay, okay,
Tomorrow you
okay,
can run it and see what it is. Okay, but you should
okay,
have permissions. Okay, just run this query configure underscore sp underscore configure. See if you're able to see it. If you're able to see this, which means that you have the permissions. Then you can run this query. Okay, or run some query, right? Select star from give a table name.
Mhm,
Okay,
mhm,
so
mhm.
select start from tab, something you run, it will show you all the tables. Okay, run some query, see if you are able to run the queries, which means that you have an access. Okay, for your
Okay,
username password. Then you can run these queries. Okay, so
okay,
you see, it has given the top 10 queries. It gave the top 10 queries. Then I said these are the queries that you need to do something about. Okay, troubleshoot or fine tune because they are taking a lot of time. Okay, then I wanted to check if the CPU is the real bottleneck or not. This is what I look for. Okay. So here, when I run the query, right? When I run the query, right, there could be a lot of results. I mean, there are a lot of columns. Okay.
mhm.
So, okay. So when I run the query, right? So can I
Kumar
create
sir,
it?
sorry to disturb. Like, shall I give the access to my SQL developer so that if you can, we can run and you can see.
Can I run it from here?
Yeah, I'll give my access.
Okay, so we will do it. Okay, so let me complete this. Okay,
Okay,
so
okay,
when
okay.
I run this query, right, so one of the output is the wait time. You see, select
Mm-hmm.
session id, status,
Mm-hmm.
blocking session id, and what is one of the thing? Wait time.
Wait time.
Okay, so what he is checking for is check the wait time in the query returned in the above output. So one of the output is what? Wait time. Okay, so you will see a
Okay.
wait time. Okay, wait underscore. Okay, so
Mm-hmm.
in the wait type, there could be multiple kinds of wait types, but if you're seeing these wait types, okay, SOS,
Okay.
schedule yield, CX packet, and thread pool. If you're able to see this, okay, if most of the queries are waiting in CX packet, revisit the SP configure setting of max degree of parallelism and cost of parallelism and check if they are as per the best practice recommendations. Okay,
Okay.
okay. So you see, CPU is the major bottleneck. Most of the sessions will have this wait types. There could be a lot of wait types. I've seen a number of wait types, but some of the wait types were actually for me thread pool and CX packet. Okay, these two were the wait types. I didn't get this wait type. Okay, so if you're getting these three wait types, right, then CPU is
Mm-hmm.
the bottleneck. Okay, CPU is the
Okay.
bottleneck.
Okay.
Get these types. Okay, remember all these guys. Abhishek, remember we're
Yes, sir.
spending a lot of time here. Everything you remember. You need
Yes.
not have to remember this query, but you
Mm-hmm.
remember this SP configure, you remember these settings, okay, and you remember these wait types, and you said that you have seen this wait type CX packet and all that, and thread
Okay.
pool. But if CX packet is what I'm, you're seeing, then go back to this SP configure, go back to this SP configure and check for these two things. What is the two things? Max degree of parallelism, okay?
Cost degree.
Max degree of parallelism, is it set to 0? Okay?
Mm-hmm.
And also cost threshold of parallelism, it is set to 5 or not. Okay?
Okay.
So you see,
Okay.
cost degree of parallelism, it is set to 5 or not. But actually for me, this was 0 and this was 5, but still I was getting CX packets. Okay?
Mm-hmm. Mm-hmm.
Okay, this is what it is so far. But now I've done some research as to what is this CX packet? What is this? Okay, because in the interview, as soon as you say I get this wait type CX packets, okay, then they will ask you what is this CX packet? Okay, you see the SQL Server CX packet is a result of parallel query execution. Okay, so if there are queries which are executing parallel and indicate that that session is waiting for the synchronization of threads involved in the parallel process to complete. While the thread is waiting to complete the workload, the remaining threads associated are assigned the CX packet wait time. Okay, so
Okay.
there are parallelly the queries are getting executed, and if one of the queries is getting executed and the others are waiting for it to get done, the other will be waiting in this wait time called CX packet.
Yes, packet. Okay.
Okay,
Okay.
so then somewhere I think I've read that these are waiting because it doesn't have enough CPU. Okay, somewhere I've read it. So let's see this one. Okay, The SQL Server CX packet wait type is the result of parallel query execution, indicates that the session is waiting for the synchronization of the threads, waiting for the synchronization involved in the parallel process of complete. By itself, the CX packet wait type is not an indication of any specific resource bottleneck. It is simply the synchronization. Okay, if you see this wait type, then that means that you have queries running in parallel on the instance, and they may be taking longer than desired. Okay, CX packet indicates that the operation of multiple parallel CPUs, each executing a portion of query. In an ideal scenario, each thread involved in the parallel execution of the query will process the similar workload. However, it is possible that one or more threads will process a larger workload than the others. While the thread is waiting to complete its workload, the remaining threads are all assigned to CX packet. Okay, so basically what it means is, okay, there are multiple threads which are running that particular query, or multiple queries, okay, which are executing in parallel. So certain queries are waiting for the actual query to get done, so they are waiting in the CX packet. Okay. So, but somewhere I saw, it is somehow it is tagged to, okay, it is tagged to CPU. CPU is less, then the CX packet will be there. That's what I have seen. Maybe I'll read some other, okay, some other blogs as well. Okay, let's read it. Let's explain. If you have the server that, okay, if you have a server that has more than one CPU core, okay, how do I know how many CPU cores are there? It is simple amount, okay, task manager, okay, somewhere here it will show you how many cores it has, okay, how many core, okay, okay, if it is not showing over here, not a big deal, okay, go to perform. Okay, and then you try to add, okay, try to add any counter related to CPU. Okay, let's say I try to add processor time, and it will show you how many cores I have. Okay, 1 2 3 4. Can you see that?
Yes, sir. What this core actually means, sir? Like,
okay, so there could be other ways of checking cores. I'll tell you what is a core as well. Okay, how do I know how many cores I have? Okay, there are other easier ways as well. Okay, so it says control shift escape. Again, they are asking me to check it from the task manager itself. Okay, but I have an older version, so it is not showing. Okay, but it is a newer version, it will show. Okay, so how many cores you have, it will show. Okay, so 1 2 3 4. Okay, CPU usage, but for me it is not showing here. Okay, because I have an older version. Okay, so those many cores, it will show you those many. Okay, if you have 4 cores, it will show you 4. Okay, are we clear, Amma?
yes, sir. Yes.
Okay, but I'll tell you how many. You see, number of cores here 2. Okay, logical process is 4. So core is what? The CPUs working, 2 CPUs working together. Okay,
Okay.
so okay, there is one CPU. Okay, here is one CPU. Okay, it can do certain amount of work, right? And let's say it is not able to handle the work, so you will have one more core. Okay, now you have 2 CPUs, as if you have 2 CPUs. Okay,
Okay.
in the same machine you have 2 CPUs, which are called 2 cores.
Okay.
Are we clear?
Yes, sir. Yes, sir.
Or what you can do is you can take a completely different machine, a complete computer, so that you have one core here and you have another computer will have another core. But why would you want to have 2 computers, right? In the same computer, if one core is not taking the work, you can add one more core. You can add one more core. And if you add one more core, the work will also, I mean, instead of 2 different machines, on the same machine, if you have 2 cores, more work will be done. That's what is also observed.
Okay.
Are we clear about?
Yes, sir. Yes, sir.
Okay. Okay. If you look at the images, somewhere they will show you. core 1, 2, 3, 4. It is more like 4 CPUs. They are working together. Okay. So okay, here somewhere it says, you see core 1, core 2, core 3, multi-core processor, core 1, core 2, core 3, core 4. This is more like 4 CPUs, but they are all put together, okay, so that the work will be done more.
Okay.
Okay, so somewhere here also it will be said a core is a part of the CPU that receives instructions and performs calculations or actions based on those instructions. A set of instructions can run. Okay, a processor can have a single core or a multi. A processor can have 2 cores, it's called dual core, 4 cores is quad core, to up to 8 cores. The more cores a processor has, the more set of instructions the processor can receive and process at the same time. Just remember, processor is to do the work. So you have more cores, you can do more work. Okay, which can make the computer fast. Okay, so instead of having 2 different CPUs, okay, or 2 different processors, not CPUs, 2 different processors, they put these 2 processors into one and they called it as 2 core. Okay, which can handle double the work of what a single core can do.
Okay.
Okay, remember those days of Pentium 3, it is only one core. Okay, it can handle so much more. But the work needs to be increased. Okay, what did they do? They created those 2 processors and then they put those 2 processors together and they said this is core 1 and this is core 2. Okay?
Okay.
Got it? So you can have up to 8 cores. Okay? So that's
okay.
Okay, so coming back. Okay, so okay, what was that? I totally lost the track.
That's yes, packet.
I think this is what we are looking at, right? Or this one? No, this is not the one. Yeah. Okay. So you see, if you have a server that has more than one CPU core, which means that you have two processes working together. Okay. You may experience a high value of CPU packet types because let's see, this is typically due to queries that are run in parallel. Okay, so the queries are running parallel and the real issue is to understand how different versions of the query can impact CX packet rates. In this tip, we examine how changing a query can impact the CX packet. Okay, the goal of the tip is to increase the query performance, decrease high CPU wait times without reducing the max stop. Okay, we will look at few of the examples of the query to impact. If you are not familiar with CX packet, you can learn from here. Okay, these wait types are all involved in parallel query execution. Whenever there is a query execution in parallel, then this CX packet will be a problem. That's what we have been understanding. Okay, these wait types indicate that the SPID is waiting. SPID is waiting on a parallel process to complete or start. Let's see the following example now. Okay, so let's look at this query, Amma. Let's try to understand. Okay, first we will create a new table. So they have created a table. Okay, create table called orders, and then they have the following rows: 1, 2, 3, 4 rows. Okay, so and then they created an index as well. Okay, fine. Okay, then insert 800,000 rows. Okay, into this table they are inserting almost 8 lakhs rows. So you say begin transaction. Okay, and then they are inserting the values into the orders. Okay, so insert into orders. So these are the values they are inserting for these things. For int, okay, for DID, OID, amount, description, they are inserting these values. Okay, and they are done. Okay, then they are inserting 8,000. Okay, 800,000. Okay, so they put a while loop. Okay, you see this while loop has begun here and the while loop has ended here, and they're continuously inserting the values. Okay, how many? 800,000 values into this table. Okay, then update the statistics in full scan so the optimizer can work easily. Okay, so update the statistics order with full scan. Okay, then they are updating this one. Okay, updating the department looks like. So create table department and insert into department values 1, 0, 3, 4, 5. Okay, and let's say. Okay, so there are looks like these 2 queries. Okay, first they have created a table and they're inserting 800,000 rows into the table, and now they're updating a statistics table. Okay, so update statistics table with this department. Okay, so is this the statistics table? This is the order table. Okay,
Audited.
so then before we begin, enable statistic times to observe the CPU time and elapsed time, include all the execution plan, clear the wait stats, and make sure the system is doing otherwise. Okay, so now you see SQL Server CX packet test one, run the query, one process and max stop one. Okay, so okay, so they are running the query to look at the CX packet. Okay, and you see there is one wait type called CX packet. Okay, as we might notice, the CPU time is very close to the elapsed time. Okay, the query is CPU bound. If not, execute the query again to make sure we are reading the data from the cache. This example to understand the parallel query execution, not this input. So we need to get the data in the cache before we continue. We execute the query with max.1. This is why the CX packet wait time is 0 before the query is executed serially. Okay, so this is
What is
max.stop.
max stop?
Maximum, what is max stop? Just now we have seen, right? Max optimize the one maximum degree of parallelism. Okay,
Okay,
max stop
okay,
is
okay, okay,
maximum
okay.
degree of parallelism. Okay, so
Okay. Since the query is working alone, so that's why CS packet is 0.
0. Okay, so max stop is 1. I mean, if the max stop is 1. Okay, so if
Mhm.
max stop is 0, which means that
0.
it's not 0 actually, it will allow it. Let's run it again in parallel. Okay, if max stop is 0, then it will allow the parallelism. Okay,
Okay.
what I understand later. Okay, what I was thinking is max stop is 0, then it will not allow the parallelism. But actually, if it is 0, it will allow the parallelism. Okay,
Okay.
so here max stop was 1, which means that at a time only 1.
1.
Okay, the CS packet there is no parallelism, so there was no issue. Okay, but now you are allowing the parallelism, and let's see what is happening. Okay,
Mm-hmm.
32 CX packets, how many are there? 33 are
53. Okay.
there. Okay, did you understand now?
Yes, sir. Yes, sir. Perfect.
So 80,000 it has executed 80,000 of them. So parallelly it is trying to insert. Then there is some what do you say? There is some parallelism going on, and some things needs to wait. Okay, some things needs to wait. Okay,
Okay. Okay.
are we clear about?
Yes, sir. Yes, sir.
Okay. Okay, so here when you say max stop is equal to 0, which means that you are allowing the parallel, right click on the cluster index seek and click on the properties to show. You can see that the SQL has distributed 100,000 across each of my 8 CPUs. So there seems to be 8 CPUs. Notice that the CPU time and elapsed time is 2221, is similar to the CX packet wait time 234, and no child threads are entirely idle, and the coordinator is the case waits for all the child threads to complete the processing about the CS packet wait time. So basically what he is saying is if there is a parallelism, then there will be a wait time because parallelly all the threads might be running. Okay, so this is what it is happening. Let's not try to understand too much. Okay, let's not deviate
Okay.
here.
Okay. Okay. Okay.
On a high level, you understood that when the queries are executed parallelly,
Parallelly.
then CS packet wait time usually happens because some queries has to wait. Okay,
Wait.
before the existing queries are completed. Okay, so max degree of parallelism is 0, which means that it allows parallelism. If it is 1,
Okay.
only parallelly only 1. If it is 2, parallelly it will allow only 2. 3, it will allow 3. 0 means any number. Max.
Okay.
Whatever
Okay.
the max. Okay, so I have done that, and there were certain other steps that you can go through, but it didn't pay too much attention. Okay, so
Okay.
then what did I do is, okay, uh, okay, so here, somewhere here, okay, uh, okay, this is what I have executed. I understood this, and now I have done something related to indexing. Let me show you what it is. Okay. This is what it is. index fragmentation on the top CPU tables. Okay, so I have to check the index fragmentation. Okay, there is something called index fragmentation. Okay, so this is a different concept as to what is index fragmentation and all that. Okay, but what we check is how is the index fragmentation. Okay, so what did I do? Query to check index fragmentation on SQL Server. Okay, in SQL Server. So somewhere here it gave me the query to check
Sir,
the.
before that, one question, like, can you tell me what is indexing in SQL?
Okay, I'll tell that. Okay,
Yeah.
so somewhere here I got a query to check the
Uh-huh.
index. Okay, I blindly executed this and it has shown me what is the fragmentation of the index. Okay, what is the fragmentation? Okay, so average fragmentation in percentage is greater than 5 and less than 30. Reorganize the index. Okay, average fragmentation is greater than 30, then rebuild the index. This is what they are giving. Okay, but I'm telling you what is index, and also let's study what is fragmentation, index fragmentation. Okay, I've studied, but I couldn't remember what it is. So first we will understand what is indexing, then we will understand or why we do indexing, then we will understand the fragmentation as well. Okay, the following is a simple query that will list every index on the table in your database ordered by the percentage of index fragmentation. I have run it and it gave me this is the table and this is the fragmentation. Okay, I have run this query, Amma. So what did it say? Oh, this is the table name and this is the fragmentation percentage. This is the table name, this is the percentage. And what they are saying, if the percentage is greater than 5% and less than 30%, you just reorganize the index. And if it is greater than 30%, rebuild the index. For us, most of the tables were greater than 30, so we have rebuilt all the indexes. Okay, this has changed a huge performance change in my project. Okay, what
Okay.
is it?
Okay.
Rebuilding the index. Now let's try to understand what is index. Okay,
Okay.
I'll open an Excel sheet. Okay, simple Excel sheet. Okay,
Like
so
a few, let me share my experience. Like, one of the interview he asked me, like, have you seen the indexing? Have you troubleshooted any indexing in SQL?
let's yeah, this is what you can say. Okay, employee, let's say name. Okay, this is an employee name. Okay, employee ID. Okay, and let's say salary. Okay, employee name ABCD. Okay, ID whatever it is 2001. Okay, salary let's say 5,000. Okay, next employee. Okay, okay, I'm just pulling it up. So this next employee name is ABC2. Okay, is okay, his ID is 2002, and let's say his salary is 2000. Okay, and then this guy's salary is 18,000. Okay, this guy's salary is let's say 6,000, and this guy's salary is let's say 7,000. This guy's salary is let's say 4,000. Okay, yeah, 80,000. Okay, 90, not 90,000. Okay, 8,000. Okay, so 90,000. Okay, and then there is another guy which says 4,700. Okay, there is another guy which is 50,000. Okay, let's say these are the salaries. These are the salaries. Okay,
Yeah.
now let's assume select this query and then the table name is EMP table. Okay, table name is EMP. Now let's say there is a query like this. Select, okay, star, okay, from EMP,
Mm.
okay, where salary is greater than 49,000, greater than or equal to, okay, 50,000. Okay, now this is a query that you have executed. What is that you're saying? I want all the people whose salary is greater than
Greater than
50,000.
50.
Okay, so what does the SQL Server now processor will do? Okay, it needs to process this query, so it will come to the table called EMP. First, it will check 5,000 and it will see if it is greater than 50,000 or not. No. Okay, then it comes to 2,000 It will check no. 18,000, check it is greater than 50,000, no. So it has to check each of the table or each of the row and say 80,000, oh, so let me get this whole table because you said star. 8,000, no. 90,000, yes, I'll get it. 47,000, 4,700, no. 50,000, I'll get it. So to get the result for this query, it needs to scan through every row or not.
Yes. Yes, sir.
So this is what we call it as full table scan.
Yeah.
Now you tell me, is full table scans good for the performance?
No.
No, because here I have only 10, but let's say there are 1 million records, and it has
Yes.
to scan through all the 1 million records. Imagine the kind of time it takes. Okay,
Yes. Yeah.
that's not good. So what people will do is they will create an index on this one. Okay, once you create an index, typically a new table will be created internally. Okay, new table will be created internally, and when you create an index, you will put an ascending order or descending order. Let's say you put when you created an index, let's say you put an ascending order. So what it will do? First, it will take this 2000. Okay, it will create a new internal table for itself, and first it will copy this one. Then the next one is this one. Okay. Okay. Next what? This one, right?
Okay. Okay. Okay.
And next is what? 6,000 wala. Okay. Then 7,000, right?
Yes.
Okay. Then 8,000. There is 8,000. No, 80,000 is there.
Total.
8, okay. 8,000 is there. Then 18,000 is there. Okay. Then what happens? If I miss out, just ignore it. Okay.
Yeah.
It's
Yeah.
just okay. Then 50,000. Then 80,000. Then 90,000. Now same query, okay, it has to execute, okay. Now, as soon as it knows that, you have reached this 50,000, they know that everything above that will be more than 50,000. It blindly will get all this information. So, is it doing a full table scan? No.
No.
You're getting the point now?
Yes. Yes, sir.
So, and here also, people usually they call this as nodes or something like that. Okay, and one, I don't remember if it is called nodes or nodes or something like that. I can't remember the exact word. I think it is node itself. First, the SQL Server processor will come and check this node one 6,000. Oh, what I want is 50,000, so it will be below this. So it will not check all this again. It will go to node 2. Okay, then it says 18,000. Oh, what you wanted is more than 18,000. And if it was another node here, node 3, okay, then it will come and check node 3. It's 90,000. No, okay, then start searching from node 2, whatever it is. Okay, here 50,000. Is it reaches? Yes. So copy all of that. So if you have, since you have these nodes, it will not even scan all of it. It will only check on the nodes and it will see whether it should go up or down.
Okay.
See how good it is? Wonderful, right?
Yes. Yes,
They're
sir.
very smart. Whoever has designed it, whoever has designed the SQL Server or Oracle, they are smart. Okay, so this is how they decrease the performance. I mean, increase the performance, decrease the time taken for the query to run it. Okay, now is it a full table scan?
No.
No, it is not a full table scan. This is not a full table scan, which is good. Performance will be improved. So this is what is indexing. Okay, now
Okay.
index fragmentation. Let me see what is. So what is index fragmentation? From what I understand is, okay, what I remember.
Okay.
What I understand is usually some information will be cached in. Okay, so if there is a difference between what has been cached in and what you have original, there is a lot of difference, then it will cause the performance issue. Okay, hang on, hang on.
Yeah.
Hello? Okay. Now, session is on. It will take a little more time. Okay, doctor దగ్గర అపాయింట్మెంట్ తీసుకున్నాం ఓకే మమ్మీ వాళ్ళు ఇచ్చిందా మమ్మీ ఇచ్చింది సరే సెషన్ కంప్లీట్ చేసుకుని 15-20 minutes ఐ ట్రై టు ర్యాప్ తిన్నాక ముందు వెళ్ళేసి వచ్చి తిందాం తీసుకుంటాం should look at this, Abhishek. Fragmentation happens when the logical order of the pages in an index does not match with the physical order of the data. Okay, so there is something called logical order, there is something called physical order. If they don't match, then the fragmentation skips. Because fragmentation can affect the performance of some queries, you need to monitor the fragmentation level of your indexing, and if required, please reorganize or rebuild the operation. You see, this is a common problem which is faced when it comes to performance. Okay, now you are thinking, okay, as to what is this logical order and what is the physical order, right? Okay.
Yes.
That's what I have done some research, and the logical order is what you have on the cache, and physical order is what you have on the tables. Okay, that's what I remember. Okay, but let's double check that. Okay, I know physical order. Let's try to understand what is logical order. Okay, what is the logical order? Okay, you see, physical and logical ordering in indexing. Okay, fragmentation will occur. Physical and logical are different, but there is a confusion what exactly is referring to physical order and logical order. Okay, fragmentation. Logical order is the order of indexing. Let's assume an index based on the last name. The logical order would be Adams, Johnson, Smith, Williams. But due to the page splits, insertions, deletes, and other things that affects the order in which pages are stored, the physical order, meaning the order of the actual storage, may look like this. Okay, Adam, William instead of Williams, Johnson, and Smith. Defragmenting will move the order of the physical storage closer to that of a logical definitions. It may be exact and it's unlikely to remain so as the data changes. Okay, so logical order is the correct order, Abhishek. Physical is how it is stored. Okay, it can store in any which way. Okay, in the pages, in the memory, it can store in any which way. But this is the order which actually it should be, because you have done the indexing on the last name. So it should say first A, then J, then S, and then W, right? Because you have done the indexing in that same order. This is what you expect, and this is the logical order, because if you try to pull out, this is what it is. But physically, where it has stored, it cannot. It may not store it in the same order. I mean, on the memory. On the memory, you can store it in any which way. But the actual order is this is the order. Okay. So if there is any difference, then there will be a fragmentation. Okay. Are we clear?
Okay.
Because if
Okay.
this is a memory, okay. If this is your memory, okay, this is your memory. So it can store it in any order here in the memory. Okay, it can store it in any order in the memory. Okay, so in whichever order, but the actual order that has to be seen is whatever is there in the logical order.
Logical order. Okay.
Okay, but physically how it is stored, it can store anywhere. Okay, first page 1 it is storing Williamson's, page 2 somewhere else, page 3 Sam or something like that. Okay, but when you run the query and all that, it will actually check it in this order. And if there is a lot of difference over here, then there will be a fragmentation. Okay, so defragmentation will remove that differences and make sure that both of them are similar. Okay. So definitely there will be some fragmentation. You cannot have a zero fragmentation, because how it is logically, how it needs to be, and how it is stored physically in the pages, it totally depends upon when you are inserting, how you are inserting, and all that. Okay, so it cannot be zero. So if it is greater than 5 and less than 30, you just reorganize the index. But if it is more than 30, you rebuild the index. Okay, are we clear? Okay, how do we do it? You just run this query and it will show you what is the percentage, defragmentation percentage, fragmentation percentages. Again, how do you rebuild and how do you reorganize? Again, I have searched for the query. What is the query to reorganize the index? It gave me, I have run the query. And rebuild the index, one more query, I have run it. Okay, do a simple Google search and it will give you. Okay, so this is the bottleneck that I have identified and this is what we have done. Okay, if you talk about this in the interview, more than enough. Okay, first you start the architecture and you say it's one host Windows Server 2008 R2 and both the SQL Server and IIS Server is installed on it because it's a simple machine, it has to support only 7280. Okay, then you looked at the Windows and CPU utilization of SQL Server is more. Then you look at configure sp_configure, looked at the settings. Finally, when I ran the query, okay, one query was there, right, which will give me the indexing. When we ran the query, it has give me the indexing, okay, sorry, fragmentation.
Fragmentation.
And the ones which is more than 60 and 30, I have reorganized this. The other one, I have, the development team has rebuilt it. Okay, see. Okay, now you can give me the access to run these queries on that. Okay, you wanted to run the query and see it, right? So
Yes,
I'll make you as a presenter. Okay, first I'll send this across to you. Okay,
okay.
let's see, where are you? Okay, Abhishek. Okay, this is one link, the main link, and also how to check the fragmentation is there on this. Okay, so these two links I'm sending it on WhatsApp. I'm making it as presenter. Okay, so you are
So
the
can you
presenter.
pause your recording for a while, like once you access my
Okay,
credentials and
okay.
all? Yeah.
So I'm pausing the recording.